NASA's just revealed images of an enormous asteroid that could destroy Earth. In our space, a diamond-shaped asteroid is hurtling towards the Earth. If the two bodies collide, the space rock, known as Bennu, is big enough to extinguish life on our planet. But the asteroid is not alone. No, a NASA probe has been chasing the massive space rock for years, and having caught up with the colossal asteroid, the craft is preparing to land on its rocky surface. Approximately 66 million years ago, a large asteroid slammed into Earth near Mexico's Yucatan Peninsula. That, in turn, triggered a cataclysm, an extinction event that led to the loss of 3/4 of the planet's biodiversity, including the dinosaurs. But the impact transformed the environment into one that allowed Homo sapiens to evolve and flourish. For decades, scientists have known that Earth faces the risk of a major asteroid collision. It's more than a risk, in fact, as the chances of a strike happening are 100% certain. It's merely a question of when. And several Hollywood movies have, of course, already imagined the asteroid apocalypse. From 1998 box office smash Armageddon, for instance. So where has this potentially devastating rock come from? Well, it's thought that asteroids were formed in the same high-energy crucible that gave birth to our solar system. These rocky bodies range in size from small pebbles to enormous hunks of stone measuring hundreds of miles across. Now, small pieces of asteroids and other space rocks sometimes fall to Earth, and although most such bodies burn up in the atmosphere as shooting stars, occasionally around 10 times a year a small piece of rock makes it to the surface. Known as meteorites, these rocky fragments often leave a small impact crater. An asteroid the size of Bennu is another matter, though. You see, the impact of such a large space rock would unleash kinetic energy equivalent to tens of thousands of atomic bombs, and the subsequent shock waves would cause earthquakes and tsunamis. There are thousands of space rocks currently traveling in close proximity to the Earth too, although close in this case refers to around 120 million miles out. Most such rocks are in fact concentrated in the area between Jupiter and Mars, but Bennu is one of 200 known asteroids with such a solar orbit, much like that of Earth, and one Bennu year is equivalent of 436 Earth days. The asteroid is certainly of note then, and scientists originally gave it the rather catchy name 1999 RQ-36. Bennu's new moniker, however, was conjured up in 2013 by 9-year-old Mike Puccio, who won a competition to rename the rock. And the youngster was inspired by NASA's OSIRIS-REx probe. At 1,650 feet wide, Bennu is a comparatively big asteroid, and the larger the asteroid, the easier it is to land a probe on it. Indeed, smaller space rocks, 650 feet across or less, tend to spin rapidly, making them unsuitable for landing on. With technological improvements, though, we may be able to explore a wider range of asteroids in the future. For now, though, Bennu is of particular interest to NASA, and the agency has sent OSIRIS-REx to learn more about the asteroid, an acronym for Origins Spectral Interpretation Resource Identification Security Regolith Explorer. OSIRIS-REx is an $800 million space probe tasked with tracking Bennu. And with the help of the craft's sensitive detection instruments and cutting-edge robotics, NASA scientists hope to extract 2 ounces of sample material from the surface of the rocky body. And there are good reasons why NASA wants to examine the sample on terra firma, the main advantage simply being that a far wider range of tests can be carried out back on Earth than in space. You see, while OSIRIS-REx boasts sophisticated technology, the most advanced scientific analysis require large, bulky equipment that can't fit on a probe. However, even if OSIRIS-REx is successful, it won't be the first time that a spacecraft has delivered an asteroid sample to Earth. Japan earned that accolade in 2010 with their Hayabusa spacecraft, and the probe's successor, Hayabusa 2, is currently en route to the Ryugu asteroid. OSIRIS-REx, though, is part of NASA's New Frontiers program, which uses smaller spacecraft to explore our local solar system. Other missions have included New Horizons and Juno, which help glean new information about Pluto and Jupiter. And having been given the green light, the mission is now well underway. The probe itself has 5 specific instruments for surveying and analyzing the surface of Bennu. The craft's visible and infrared spectrometer, OVIRS, will be used for detecting organic chemicals and minerals by measuring both near-infrared and visible light. Secondly, the probe's thermal emission spectrometer will measure the rock's temperature. Like the OVIRS, the device will also locate concentrations of chemicals and minerals. And together, these 2 instruments will enable NASA scientists to map the surface of Bennu and choose the most interesting site to extract samples from. The third array of instruments is a high-resolution camera suite composed of 3 units: Polycam, Mapcam, and Samcam. Polycam will gather initial images of the asteroid as well as potential sample sites, and Mapcam will then scour the rock for satellites and stitch together topographic maps. Meanwhile, the OSIRIS-REx laser altimeter (OLA) will conduct a detailed scan of Bennu's surface, and the data that the instrument collects and relays back to Earth will be used to create extremely detailed models of the asteroid in 3D. Interestingly, similar technology was recently used to reveal the location of Mayan pyramids in the jungle. Finally, the probe is also fitted with a regolith X-ray imaging spectrometer, REXIS, which will detect the X-rays coming from the asteroid, and the results collected by this device will contribute data to a map of the rock's elemental properties. Specifically, the information gathered by the REXIS will reveal the atomic structure of the asteroid. OSIRIS-REx should help experts discover new information about our solar system then. Indeed, just as the fossil records contained within the strata of the Earth underpins our knowledge of geological time, so the asteroids in our solar system are vital to our understanding of cosmic time. NASA is also interested in the theory that biological life could not begin in Earth's primordial ocean. Rather, life migrated to our planet on an asteroid. And interestingly, Bennu appears to have a particularly high level of carbon-based components. Further analysis of the space rock's composition may yet provide new insights on the origin of life then. There's the asteroid's monetary worth too. That's right, the rock could be a valuable new source of resources. Mission will develop important technologies for space exploration that will benefit anyone interested in exploring or mining asteroids. Dante Loretta, OSIRIS-REx principal investor, explained in a space agency press statement in 2013. Whether that interested party is a private enterprise or a space agency such as NASA is hard to say though, but given the recent growth of private investment in the space sector, it's not hard to imagine a future where asteroids are regularly mined for fuel or metallurgical resources. Above all though, the data gleaned from the mission will enable scientists to better predict the trajectories of asteroids and presumably influence their respective courses. But one possible application of such knowledge could be terraforming, the intentional alteration of a planetary body in an attempt to make it habitable. In 2017, for example, scientists from the Lake Matthew team proposed a scheme called the Mars Terraformer Transfer. You see, the scientists say that such a collision would cause the Martian bedrock to heat up and release its frozen groundwater. This in turn would create a lake lasting for millennia. And it's theorized that the water from the new lake could then be used to supply a city-sized colony, effectively sidestepping the big technical challenges of terraforming an entire planet. OSIRIS-REx could be crucial to the future of our planet then. And having launched in September of 2016, the probe's first maneuver involved setting up for gravity assist before performing a flyby of Earth. This slingshot strategy, intended to add speed for the onward voyage, saw the craft use our planet's gravitational pull to catapult itself into space. And it seems that the probe's flyby of Earth went perfectly. It brought the spacecraft within 11,000 miles of Antarctica, in fact, and caused it to accelerate by an additional 8,500 miles per hour. What's more, before departing for the distant asteroid of Bennu, OSIRIS-REx took some haunting images of the Earth and the Moon. Then on December 3, 2018, OSIRIS-REx came within sight of its target. It marked the end of a 27-month chase that had taken the probe over 1 billion miles through space. Now though, NASA scientists would have to perform the tricky task of putting the probe into orbit around Bennu. To complete the move, the expert team first had to take detailed measurements of the rock's shape and mass. Maneuvering around a small body that basically has no gravity is very challenging. Heather Enos, deputy principal investor at OSIRIS-REx, explained to Space.com. So we have to get a little more information to proceed every step of the way. But NASA safely placed OSIRIS-REx into orbit around the asteroid on the last day of 2018. And in doing so, the space agency established a couple of records. Firstly, Bennu became the smallest space rock ever to be orbited by a spacecraft. Secondly, the probe broke the record for the nearest orbit of a body that small in space. And at one point, the craft traveled just a single mile from the asteroid's surface. Locked in orbit around Bennu then, OSIRIS-REx has since been conducting surveys of the asteroid's surface. The probe will generally complete flybys at a distance of around 4 miles and has been charting the asteroid's north and south poles as well as its equator. Of course, the biggest decision concerns where exactly to land the probe. The sample site will in fact only be selected after 1.5 years of data gathering and analysis. Mission managers will then present 2 potential landing sites in July 2020, and the winning location will be selected shortly thereafter. And after this decision's been made, OSIRIS-REx will carry out its next important task. Yes, the probe will then move in to collect a sample. However, the landing will be extremely brief, so fleeting in fact that OSIRIS-REx scientists have compared it to a kiss, lasting just a couple seconds. That short period, though, should be enough for the craft to acquire its sample. At least that's the idea behind its touch-and-go sample acquisition mechanism, TAGSAM. Indeed, TAGSAM does the work of digging and collecting rock. Using blasts of nitrogen gas, the device fractures the surface of the asteroid to release broken rock and dust, which is then collected inside a sample chamber. And to allow for several attempts at obtaining a sample, the probe carries 3 gas-filled chambers. For the mission to be a success, then, NASA must acquire a minimum of 2 ounces of asteroid material. However, to compensate for any measuring errors, they'll attempt to gather around 5 ounces. And should the mission demand it, TAGSAM actually has the capacity to carry an additional 70 ounces. Once the sample has been collected, OSIRIS-REx will commence its long journey home. The return trip is scheduled to start in March 2020 and will take some 2.5 years to complete. Then, in September 2023, the probe will dispatch its cargo of asteroid rock. But while Bennu is certainly capable of inflicting disaster on Earth, the asteroid is unlikely to ever actually hit our planet. In fact, according to NASA, there is a 1 in 2,700 chance that the rock will hit Earth in the 22nd century's final quarter. For that to happen, though, the asteroid's present track would have to change during its 2,135th orbit. There is, however, still an important reason for NASA scientists to conduct a thorough risk assessment of the rock. The Yarkovsky effect, the theory discovered by Polish engineer Ivan Yarkovsky, refers to the way an asteroid's path can be altered over time by the sun heating the rock's surface. An unpredictable Yarkovsky effect, then, could potentially cause Bennu to be redirected towards Earth. But even if Bennu were to collide with Earth, a hypothetical doomsday impact is actually a matter of dispute. Yes, while British tabloid The Sun has compared a potential impact to 80,000 Hiroshima atomic bombs, experts believe the destruction would likely be limited to a more localized area. An extinction event is therefore unlikely. Nevertheless, the possibility of an asteroid colliding with the Earth at some point in the future is almost completely certain. Whether or not humans will be around to experience it, much less have the technology to avert it, is less certain. But in any case, there will always be a sensible, powerful, and scientific argument for studying space rocks.